Okay, on the top of page 11, this is actually a very common problem. You've also seen these ladder problems in calculus or pre-calc. So here this says that we have a 17-foot ladder is leaning against a wall. Okay, and at the bottom, the ladder is being pulled along the ground at a constant rate of 4 feet per second. So this is a derivative value. How fast, okay, so we want another rate, will the top of the ladder be moving down the wall when the ladder is 8 feet above the ground? Okay, so a couple things. First of all, what we need to do is sketch. So we have our wall, we have the ground, and then we also have our ladder. So in this case, our ladder is 17 feet long. And this is a constant value. So this actually goes back to the strategy where this value will never change. This is the type of ladder that does not change. Okay? And they're saying that if the bottom of the ladder is being pulled along the ground, meaning pulled that way, at a constant rate of 4 feet per second, when we're talking about a triangle, more specifically a right triangle, this is usually your x value. So this would be dx dt is 4 feet per second. Okay? And they want to know how fast the top of the ladder will be moving down the wall. Okay, so they want to know dy dt. When they say how fast or at what rate, it's a derivative. So this is our unknown value. This is what we want. All right, so then they also want to know how fast will the top of the ladder be moving down the wall when the ladder is 8 feet above the ground? Meaning I have a value up here. They're looking to say, okay, how fast is it moving when this is 8 feet? So that means my y value will be 8. I have an r, or let's just call this z, is equal to 17, and we need to know what x is. This is actually a special value, but if you didn't know that, you could use the Pythagorean, which is x squared plus y squared is equal to 289. So you might need a calculator for this. Actually, for a lot of these problems, you will need a calculator. So we're going to take 289, subtract 64, we get 225. So that means x is equal to 15. Okay, so I have x is equal to 15, y is equal to 8 because they gave us that, and z is equal to my ladder, which is 17, and this will not change. So what we have here is x squared plus y squared is equal to 17 squared. Now, if you remember in the strategy, it said you can only plug in a value if you know it will never change, meaning this rate of change can be different depending on how fast someone is pulling that ladder down the wall. This is never going to change. Your ladder will always be 17 feet long. That's what they gave you. So now when we take the derivative with respect to time, we have 2x dx dt plus 2y dy dt is equal to, this is 289. The derivative of that is 0. I could actually save myself some time and make this problem a little bit easier by dividing everything by 2, leaving me with x dx dt plus y dy dt is equal to 0. Now let's plug in what we know. So when I'm looking here at what I want to find is dy dt, which means I should have a value for every other variable here, meaning x, dx dt, and y. We found x, we were given y, and we were given dx dt. So let's plug in what we have. So x is 15 feet, dx dt is 4 feet per second, and then we also have y of 8 feet, and we have dy dt. Now, here, this is moving down the wall, so that implies that my answer will be negative. Okay, so let's multiply everything out here. So when I do that, let's see, I've got 15 times 4 is 60 So I have 60 square feet per second. I'm going to move this over here, is equal to -8 feet dy dt. So if I'm solving for dy dt, I'm going to divide or multiply by the reciprocal. So you have 60 square feet per second times 1 over -8 feet is equal to dy dt. This will cancel with this. So you end up with a decimal of -7.5 feet per second is equal to the rate of change that the ladder is moving down the wall. So if it asks you, sometimes in the multiple choice you'll see the negative, and sometimes you won't, depending on how you describe. So you just need to be aware that this negative is because our ladder is moving down the wall.